You might want to go ahead and try these 4 examples on your own and then watch this video to check and make sure you did them correctly. We're going to work through them pretty quickly. On the first one, it's in factored form. It's in standard form, so we can go ahead and look at the highest power of x, which is x squared. X squared over x squared reduces to 1, so that's a y equals 1 for that horizontal asymptote. For vertical asymptote or holes, it needs to be in factored form. I can factor a GCF of x out of the top, so x minus 2. The bottom will factor as x plus 2, x minus 2. Then the factor that cancels out is the x plus 2. The factor that does not cancel out is the factor that cancels out is the x minus 2. The factor that does not cancel out is the x plus 2. So the x plus 2 gives me a vertical asymptote of x equals negative 2. The factor that does cancel out gives me a hole of x equals positive 2. If that's the x coordinate of the hole, I can always plug the 2 in for both x values. And that gives me the y coordinate of the hole of 2 over 4, which reduces to 1/2. 2 over 4 reduces to 1/2. If I was going to, I could always try this with Desmos, but if I was sketching the graph, here's what it's going to look like. I'll do my asymptotes in blue, maybe. So asymptote of x equals negative 2. Something like that. Y equals 1, something like that. The whole of the graph, go ahead and do the graph in green. The whole of 2 1/2 lets me know that the point is going to be a little bit below at about 2 1/2. That means this branch of the graph must look something like this. It means the other branch of the graph is probably in the opposite corner. I could always use Desmos to double check these because these rational graphs are kind of unique on their own. We'll go through the others very quickly. This one is actually in standard and factored form because there's nothing to factor there. So the vertical asymptote is what makes the denominator equal 0, x equals negative 2. There is no hole because there is no factor to cancel out. And once again, there's no need to rewrite that. It's exactly the same. Horizontal asymptote in this case, the highest power is x, so I would fill in a 0x over the 1x that was already on the bottom. So that gives me a y equals 0. And once again, one of my hints was if the power in the denominator is bigger, you're going to have a horizontal asymptote of 0. On this one, the power in the denominator is bigger again, so you have a horizontal asymptote of 0 because you'd be doing 0x squared over x squared. Vertical asymptote, this one, is also in factored form because the denominator will not factor. But what we have unique going on with this one is x squared plus 1. If I try to set x squared plus 1 equal to 0 and solve for x, I'm going to end up taking the square root of a negative, which would give me an I. Well, I cannot graph an I solution, so the truth is this has no holes. It has no vertical asymptotes. The domain of this is actually all real numbers. This is a unique rational equation because it does not have any domain restrictions, but that's because the only factor doesn't have any real number solutions or x-intercepts. So therefore, that's why it works out that way. This last one is actually one like the top of the page, just threw it in there to let you make you notice that if you do not have any variable in the numerator, you can go ahead and treat it like the translation. So the x-intercept is x equals negative 1 because I would have gone to the left 1 because of that plus 1. And the y-intercept is a minus 4 because I would have gone down 4 on the bottom. And this one has no hole because there was no factor that canceled out. And let's see, that is what there is there. Now, if you wanted to, you could have gotten a common denominator with this one and basically multiplied this 4 by x plus 1 top and bottom. And you could have translated into the normal standard form, but there was no need to have to do this. If I would have done that, I'm going to go ahead and write this over here to the side. That would have given me a negative 3 minus 4x minus 4 on top. And on bottom, everything would have had a x plus 1. And notice that would have given me a negative 4x minus 7 over x plus 1. Then comparing my highest degree, which is my x, it would have given me a negative 4 over 1 for the same y-intercept if it would have been in that form.